Next question. Find the domain and range of the following real functions. First one is f of x equal to minus mod x. So what you have to find is we have to find the domain and range of this function f of x. F of x is defined as minus of mod x. So to find the domain, what we have to do is we have to check the values of x. To find the domain, we have to check which all values x can take. Okay, we will start with the real numbers and then make set smaller in size, integers, whole numbers, natural numbers, like that. Okay, so domain, first of all we will start with the real numbers. So domain is those set which satisfies the x value. And to find the range, what we have to do is we already calculated the domain by substituting the value of x. What we get for f of x, that will become the range. So domain is what we have to find is we have to find the x values, which all x values can satisfy the function. Those set defines the domain. And for the domain, when we substitute each value of x, whatever set we get as f of x, that will become the range. So I told already, we will start with the real numbers. Okay, and we have to check whether modulus of x is possible for all the real numbers or not. Modulus of x means if I want to find modulus of a positive number, modulus of 5 is 5 itself. If I want to find the modulus of a negative number, then also it is 5. Modulus of 0, it is also defined as 0. If I want to find the modulus of a fraction, modulus of 1 by 2 is 1 by 2. Modulus of a negative fraction, that is again 1 by 4. It was a fraction. So every number is defined, isn't it? So when we take 5 minus 5 0, that means negative integer 0 or fraction, it is defined. That means x can take any real value. X can take any real value. That means the domain of the function is R, real numbers, set of real numbers. Okay, again to find the range, what we have to do is we are substituting real numbers in place of x. When we substitute a positive number in place of modulus of x, suppose I am substituting x as 5, then modulus of x will be 5. Okay, and our function definition is minus of mod x, isn't it? So f of x will be equal to minus of modulus of 5. So minus of mod 5 is negative 5. So we are getting a negative number. When we take x as minus 5, then also we are getting f of x equal to minus 5, which is a negative number. Whichever value x takes, either positive or negative or 0 or fraction, modulus of x will be positive number, but negative of that number will become a negative number. That means f of x will always be a negative number. Okay, 0 can also be there. Modulus of 0 is 0, minus 0 is actually 0 itself. So 0 and negative numbers are there. So range we will restrict to negative numbers. How we can define the negative numbers as interval? We can define the negative number as open interval minus infinity, closed interval 0. Why? Because 0 is possible. Clear? To find the domain, what we have to do is we have to check which all values the function x can take. So here it is modulus of x. Every real number has a modulus. So domain will be equal to the real number r. Again, to find the range, what we have to do is we have to substitute x as real numbers and check what does minus of mod x. Whatever value x takes, modulus of x will be a positive value and negative of modulus of x will be a negative value. Therefore, range will be a negative numbers. Negative numbers means we can have all the negative real numbers are there. That is the reason why we are expressing it as minus infinity 0. Here it is closed. Why? Because modulus of 0 is 0 and minus modulus of 0 is 0. So f of x can take the value 0 also. That is the reason why we are taking the interval as minus infinity, open minus infinity and closed 0. That will become the range. Okay. For the next question, f of x equal to root of 9 minus x square. We have to find the domain and the range. So what I told us, to find the domain, we have to check whether which all values x can take. It is root of 9 minus x square. This root cannot become a negative value. If I am substituting the value of x as 2, this root of 9 minus x square becomes a root of 5. It can happen, isn't it? If I substitute x as minus 2 also, it can become root of the same value, my x 9 minus 4, which gives the value root of 5. That is possible. So if I substitute it as x as 4, what about this value? Root of 9 minus 16. That will become a negative number inside the square root. That is not possible. So x cannot take the value 4. Okay, x cannot take the value minus 4. Why? Because if I substitute 4, we are getting a negative value. If I substitute a minus 4 also, we are getting a negative value inside the square root, which we don't know the value now. Okay, again, if I am substituting the value of x as 5, 6, 7, 8 or minus 5, minus 6, minus 7, minus 8, etc., then also the same condition holds. Root of a negative number comes. So x cannot take a value greater than 3. If it is taking the value 3, what happens is 9 minus 9. It becomes 0. Root of 0 is defined. Okay, so the maximum value x can take is 3. And can you say which is the minimum value x can take? X can take the value minus 1, x can take the value minus 2, and in between minus 1 and minus 2, x can take all the real numbers. X can take the value minus 3 because minus 3 square is 9, 9 minus 9 is 0. What about minus 4? No. Why? Because the same reason, root of a negative number will come. So the least value x can take is minus 3. So x can take the value from minus 3 to 3. Clear? X can take the value from minus 3 to 3, including minus 3 and 3. So the domain of the function, domain of f of x will be closed interval minus 3, 3. Okay, to find the range, what we have to do is, this is the domain. We have to substitute each and every element inside this bracket, inside this closed interval to this function to check the range. To check the range, what we have to do is, if I am substituting the least value minus 3, what I get is 9 minus 9, a root of 0. If I substitute 3 also, it is 9 minus 3 square, that is 9 minus 9, 0. Minus 3, 3 means if I write the real number, minus 3, minus 2, minus 1, 0, 1, 2 and 3. So these much numbers are there in the domain. Okay, if I substitute minus 3 and 3, the same value will come since it is 9 minus x square. If I substitute minus 2 and 2 also, same value will come, root of 9 minus 4. If I substitute minus 1 and 1 also, same thing, root of 9 minus 1. If I substitute x as 0, that will become root of 9 minus 0, which is root of 9, 3. So can you say what is the range? The maximum value this f of x can take is, the maximum value this function can take is 0. From where I got 0? The least value, when I substitute the least value of x as minus 3, I am getting f of x as 0. When I substitute the greatest value 3 from the domain here in f of x, then also f of x becomes 0. So the maximum value x can take, means f of x can take is 0, including 0. Okay, then can you say which is the least value x can take? X can take the least value when I substitute the value as 0. Why I am choosing 0 is because in between these numbers, the positive numbers and the negative numbers remains the same when substituting in 9 minus x square. Same way, in the between numbers minus 1 and minus 2 and 1 and 2, though the numbers are different in sign, when we substitute here in f of x, the value gets the same because it is x square. Okay, so when we substitute minus 3 or 3 in f of x, we are getting the value 0. Okay, again, when I substitute the value of f of x as, x as 0, it becomes, f of x becomes square root of 9 minus 0. That is square root of 9, which is 3. Okay, so the maximum value x can take, f of x can take is 3 and the minimum value f of x can take is 0. So range is equal to closed interval 0, 3. Range, how we will calculate? We already calculated the domain. We have to substitute each and every value in the domain in f of x to get the range. Okay, when we substitute, we are not able to put all the values. Why? Because it's a real number and there are infinitely many numbers. So we can try it some. So when we substitute minus 3 and 3, root of 9 minus x square will become 0. When we substitute x as minus 2 or 2, it becomes root of 9 minus 4, which is root of 5. Okay, when we substitute minus 1 and 1, we are getting square root of 9 minus 1, which is root 8. And when we are substituting x as 0, we are getting root of 9 minus 0, which is 3. Root 9, which is 3. So the number variations are from 0 to 3, including 0 and 3. That is the reason why range we got as closed interval 0, 3. So for the function root of 9 minus x square, domain is minus 3, 3 and range is 0, 3. Then without calculating, can you say what will be the domain of square root of 16 minus x square? If the question is to find the domain and the range of 16 minus x square, just compare. When it is 9 minus x square, we got the domain as minus 3, 3. Isn't it? So what will be the domain here? It will be equal to closed interval minus 4, 4. Okay. How I got as x square equal to 16. So x equal to plus or minus 4. That will be the least value and the biggest value when the function is like this. And what about the range? When it is root of 9 minus x square, we got the range as closed interval 0, 3. So when it is 16 root of 16 minus x square, can you say the range? Range will be equal to closed interval 0, 4. Okay. See, again, if the question is f of x equal to square root of 25 minus x square, what will be the domain? Domain will be equal to closed interval minus 5, 5. And the range will be equal to closed interval 0, 4. Clear? Again, suppose f of x equal to 14 minus x square. Then what will be the domain? Domain will be equal to closed interval minus root of 14 to root 14. And range will be equal to closed interval 0 to root 14.